So let's talk about our last two rules for finding derivatives. First, we've got the product rule. How do we find the product of two functions? They have to be in terms of the same variable. And it's often tempting to say, oh, well, I'll just take the derivative of the first function times the derivative of the second function. But unfortunately, it's not quite that easy of a process, okay? So how do we find it? Well, here is the product rule, which is basically saying I've got the derivative of two functions, f and g, that are both differentiable functions. They're in terms of x in this case. All right, so what is this notation saying? So let's write it where we can make sense of it in words. And I like to refer to it as my first function and my second function. Okay, because we're not going to see any notation like f and g. We're just going to see the function, the expression itself. All right, so what is this derivative saying? Well, it's saying f prime of x. Well, my first function is f. So ultimately it's saying what's the derivative of the first function. Okay, so that's what we're going to do. We're going to find the derivative of the first function, and then we're going to take that times g of x. Well, g of x is my second function. No derivative, just the second function. Okay, so I'm just going to write second to make it shorter. All right, plus, and if you think about many things we do in algebra and math, multiplication goes with addition. For example, exponent rules, logarithm rules. Logarithm of a product is a sum. And so it's just kind of a common thing, so we can help remember it that way. Then it says plus f. Well, f of x is my first function, so now it's just the first function itself, exactly as it is. You don't have to take any derivatives. And then you take that times g prime of x. Remember, the prime means the derivative. So then we take that times the derivative of the second function. So if you notice, we're taking the derivative of one function times the other one, both ways, and then we're adding it. Okay, so if you actually switched the order, it wouldn't matter because addition is commutative. However, when we do the quotient rule, that's not the case. So I usually always follow this pattern, and this pattern transfers nicely over to the quotient rule. Okay, so let's look at a couple functions that are a product of two different functions. Example, here I have p of x. It's a product of two polynomial functions, which we could actually find the derivative if we would distribute and multiply that out into one big polynomial. Then we could find the derivative of each term, but sometimes that's more tedious, but it's an option. Okay, but let's use our product rule because that's what we're trying to learn in practice. All right, so the derivative is p prime of x. Before I do that, I like to talk about my first and second. So this is my first function, 7x plus 1, and my second function is x squared minus 5. All right. So what I'm going to do is I'm going to write it out to remind myself as I go. And sometimes because of time, I might call it F and S, just because. All right, so what does it say? My derivative is to find the derivative of the product. I take the derivative of the first function, so I just call it F prime, times the second function, I just call it S, plus the first function itself, no derivative, times the derivative of the second function, which would be s prime. So just kind of a notation I like to use. It doesn't matter what you do. I will recommend, though, that you just say it to yourself every time so you remember it as you do it. Okay? All right. Oh, man, Okay, so then I'm basically filling those things in. And I use parentheses to keep things straight because we are doing multiplication. All right, so the derivative of the first, what's the derivative of 7x plus 1? It is 7 times the second function, which is just x squared minus 5, plus the first function. So now I just copy down my first function, which is 7x plus 1. And then I find my derivative of my second function. The second function is x squared minus 5. So the derivative of x squared minus 5 is 2x. Okay, as far as I'm concerned right now especially, you can leave it like this. You do not need to simplify. All right, now this one I think is tricky because it's hard to see that it's two different functions because I don't have parentheses. They don't typically do give you the parentheses unless there are two terms. So what I like to think of is this is a product of two different functions. So my first function is a polynomial or a monomial, one term. And my second function is an exponential. So I have a polynomial times an exponential function. So there are two different types of functions. That's how I can tell that it is a product. But I typically like to rewrite it using parentheses so I know it's a product and I know which is my first and which is my second. So that's the product of negative 7x squared and e to the x. Okay, so we're using the product rule. And then I'm going to call this my first function and this my second function. If you want to use f and g, that is totally fine. So my derivative, so it'd be the derivative of y with respect to x. My notation here is going to be, all right, so I'm going to take the derivative of the first function, which the derivative of the first function, derivative of negative 7x squared is negative 14x, using the power rule and all of our basic rules, okay, times the second function. The second function is e to the x. All right, so that's the derivative of the, that's the second function. Whoops, I see what I was doing. That's the second function. Plus the first function times the derivative of the second function. Okay, so my first function is negative 7x squared. Now my second function is e to the x. Well, what's the derivative of e to the x? E to the x.